So the role of MEP engineer in retrofitting project is to find right balanced MEP solutions within the existing building's spatial and structural constraints. That's to give a new life to the buildings so it can fulfill its inherited possibilities and potentials. Finding flexible and future-proofing MEP solutions, it can secure many more years for the building's life. The difference between new build and retrofitting project is for new build, there are design flexibility in locations and size of MEP occupied spaces, while retrofitting buildings projects often requires to adapt the existing MEP plant room and riser spaces to be fit to the new MEP systems, and that's the biggest difference we see. Modern MEP systems requires more plant spaces due to a low energy design. For example, low fan power usage results in larger ductwork spaces required. And that's the right thing to do to save the energy. So absolutely right thing to do. However, for retrofitting existing building, existing MEP plant room and risers spaces are limited and often difficult to enlarge for other good reasons, such as structural significance and heritage or planning impact. This is the common challenge I've faced many times. And in the past, the key to solve this is to reduce the energy demand of the existing building to start with, especially heating and cooling energy demand, by working with the building fabric improvement. Then we'll have a fighting chance. This is a good question and often comes up when we are working with listed buildings. In short, it is striking the right balance between MEP systems and existing buildings limitations. Any implementation needs to be done sensitively to the heritage value. Having said that, we are no longer in the world where heritage and listed building status means don't worry about operational energy. So we must do all we can to reduce the energy demand, which goes back to the previous point about improving the building's fabric performance, as well as deploying low energy MEP solutions. In my opinion, for relatively modern heritage building, such as 1960s to 80s brutalist buildings, successfully implemented fabric improvement and energy demand reduction systems would make these buildings even more attractive. For many buildings I came across had poor record of information, especially existing MEP systems, but sometimes even for structural information. Or sometimes we came across buildings with thousands of paper copies building information. This takes significant amount of effort and time, and still often found ourselves having inaccurate knowledge about these buildings. So new technologies are helping retrofit area, and previously we have used 360-degree camera with digital reconstruction of the recorded space, which is relatively quick and easy things to do, and it allows us to be able to measure distances of the recorded spaces from wall to wall, floor to ceilings on our computer later on. On other more major scale of retrofit projects, we have managed point cloud survey, and survey BIM model. This takes more time and money, but it is a very strong tool for retrofit design development. These technologies are helping us on the retrofit project. So MEP engineering deals with things that we cannot easily see. That's air, that's energy and electricity and a bit of water. It is really hard to grasp. However, that engineering challenge of achieving beautifully integrated design with our architectural colleagues and other engineering colleagues is what made me choose MEP engineering. MEP engineering, when it works so well that no one notices. As an engineer, we all feel our social responsibility and great contributions that we can make to better the world. We MEP engineers have a significant role to play to control the energy use in the society and decarbonize the built environment. It is truly a rewarding career. I would say Imperial War Museum in London. This project was refurbished and significantly remodeled the existing building. We have removed a significant part of the ground floor and created triple height space, which is capped with another new floor floating in the museum space. One of the challenges we came across on that project was in the catering kitchen area. We found downstand beams, structural downstand beams that is blocking, it was never in the record information, and it would have been blocking our MEP services. So that was discovered in construction. So quickly the design team, our structural engineer, ourselves and MEP and architects got together to resolve that coordination. And in the end, we found a great solution to be able to tackle that challenge. Retrofit is important. Doing the retrofit in the right way with a long-term view is very important. UK has committed to the 2050 net zero, and the majority of the buildings at 2050 are already built. They are existing buildings. So tackling the existing building stock is the key part of decarbonizing the built environment. Operational energy and carbon emission from the existing buildings in the UK amounts for 19% of the country's total carbon footprint. Thinking on this and contributing to such a significant topic of our generation excites me. Doing the retrofit right will benefit our clients and our society by making the existing building more attractive, by elongating the life of the existing building stocks, and by reducing the operational carbon footprint of those building stocks.